Hi guys, welcome back to Z Physics. Today we are going to be doing a practice past paper question on Newton's second law of motion and impulse. Okay, well, let's get started. This is a question from OCR Physics A from June 2013. First question is asking us to state in words Newton's second law of motion. Now, Newton's second law of motion is that the resultant force, let's just write this down, the resultant, we can also write net force, is proportional, so the resultant force acting on an object is proportional to the rate of change of momentum. To the rate of change of momentum. Now, quite a typical error is to forget to include the rate of change. Now, some students might write that the resultant force is proportional to the change of momentum. Now, unfortunately, this is wrong because the equation is that F is equal to delta P divided by delta T. Now, every time you're dividing by an increment in time, in this case that's delta T, that's the rate of change. For instance, acceleration is the rate of change of velocity. Okay, part 2. Show how this leads to the expression F is equal to ma for an object of constant mass. Okay, well, F is equal to the change in momentum divided by the change in time. Now, momentum is equal to mv, so that's the change of mass times velocity divided by delta t. It's really important to have those brackets in this derivation to make sure that this delta, this change in, actually applies to both of these objects. Now, because m is constant, so I'm just going to write m is equal to a constant, we can take this out of the change because there's no change in the mass. So the net force in this case will be equal to m delta v over delta t. Now, this is actually acceleration, the rate of change of velocity, so this is equal to ma. Okay, so for part B, this is giving us a graph of force against time. The question is asking us to determine the change in velocity of the object. Now, anytime we have a force against time graph, then the area underneath the curve is equal to the impulse. So I'm just going to write this down. So our area under the graph will be equal to the impulse. Now, impulse is essentially the average force multiplied by the time it acts upon an object. We could calculate the area by just using the formula that the area will be a half the base times the height. So our area in this case will be half times 4. I'm just checking the units because often they would give us some non-standard units. However, in this case, they're fine in seconds. And additionally, on the y-axis, we have newtons. So our area will be a half times 4 times 20. And if we multiply those numbers out, we are going to get 40 Newton seconds. Okay, so once again, the area is just a half times base times height, so a half times 4.0 times 20, and this will be equal to our impulse. So this is just equal to 40 Newton seconds, and this is our impulse. Now remember, impulse is actually equal to our change of momentum. Why is that? Well, remember Newton's second law. We'll just use that in a different color on the side. Newton's second law says that the net force is equal to the rate of change of momentum, delta P divided by delta T. If we just rearrange for F delta T, this will be equal to the change in momentum. This quantity over here on on the left, that is our impulse. So the impulse is just here. This is equal to the change of momentum. So 40 will be equal to our change of momentum. What we need to find out though is the change in velocity in this question. So because the mass is constant, 40 will be equal to the mass times the change in velocity, i.e. the change of velocity will be equal to 40 divided by the mass, which is equal to 40. The mass in this question is equal to 2.5 kilograms. So that's going to give us a change of velocity, which is equal to 16 meters per second. Now, how do we calculate the mean acceleration? In this case, we know that the force is acting for 4 seconds. So it's acting from here to here. So we can calculate our mean acceleration simply by the fact that A is equal to the rate of change of velocity. We know that the change of velocity is 16, and we know that the time that it acts on is 4. So if we just divide those numbers, we're going to get a mean acceleration of 4.0 meters per second per second. Okay guys, and here is the solution to the last question. Describe how the acceleration of the object varies between 0 and 4.0 seconds. Now, first of all, between 0 and 2 seconds, the force is increasing. Now, if the force is increasing, because F is equal to ma, the acceleration is constant, so just over here, if the force is increasing, the acceleration is also increasing. So in that first region, the acceleration is increasing. It's also increasing linearly, and that's really important to note. If we can tell in our answer what the rate of acceleration, or what the rate of change of acceleration is, we should do. In this case, we can see that the force increases at a constant rate, i.e. linearly. Similarly, from 2 to 4 seconds, the acceleration is decreasing linearly from 2 to 4 seconds. Okay folks, so hopefully this makes sense. If there are any questions about impulse or Newton's second law, please leave a comment, and thank you very much for watching.